Hi everyone, this is Ankit from EcoSikho and I'm back with another video on our IB syllabus, and in this video we are going to talk about quadratic functions. So before we jump into the syllabus, let me ask you something. If I have a ball and if I happen to throw the ball up in the air, will it go on forever? The answer is no. It rises, it slows down, and then it finally comes back. That entire journey, up, turning point, and down, can be explained by just one function. And that function is y is equals to ax squared plus bx plus c. And in our syllabus, this is not just an equation. This is the language of motion, profit, loss, design, and even decision making. So in IBDP Maths AI, quadratic functions are not just about memorizing formulas. They are about understanding behavior. Where is the maximum? Where is the minimum? When does something stops increasing and starts decreasing? And trust me, once you understand this, graphs stop being scary, questions become predictable, and marks starts to increase. So by the end of this video, you will be able to look at any quadratic graph and instantly tell me its shape, its turning point, and what it actually means in real life. So before any further ado, let us jump into the syllabus. So what is a quadratic function? Any equation that has a degree of 2 is called as a quadratic function. What do we mean by degree of 2? The maximum power. If I have an equation that looks like y is equals to ax plus b, this is something we call as a linear equation. But if I have an equation that looks like y is equals to ax squared plus bx plus c, this is something we call as a quadratic equation. In our case, we are calling it as a quadratic function. So in this quadratic function, your a, b, and c, they are real numbers. And a is not equals to 0, because if a becomes 0, it will become a linear equation. And your x and y, they are variables. Okay. So let us talk about the graph of a quadratic function. So whenever I try to plot a quadratic equation into a graph, I get something that looks like this. This particular shape is called as a parabola. And the point where this parabola turns, okay, so in this case, the parabola was going down, down, down. Then at a point, it turned. It started climbing up. So this point where the parabola turns is called as a vertex. And if I try to draw a line which is perpendicular to the x-axis and which also happens to pass through the vertex, I get something known as the axis of symmetry. We call it the axis of symmetry because it divides the parabola into two equal halves. So after drawing this axis of symmetry, I can see two halves of the parabola. One is the left half and the other one is the right half. And these two halves are equal. Okay. So we might have a parabola that is going towards up, that has its mouth open towards up, or we might have a parabola that looks like this. So the first one is what we call as a concave upward. So this is your concave upward parabola. And this over here is your concave downward parabola. Okay. So whenever the parabola crosses the y-axis, we get something known as a y-intercept. And whenever a parabola crosses the x-axis, we get something known as x-intercept. So for example, if I have a parabola that looks like this, so these 2 points are your x-intercept. Okay. So one thing that we should be clear with is x-intercept are not the root to the equation ax square plus bx plus c is equals to y. But x-intercept are the roots to the equation ax square plus bx plus c minus y is equals to 0. Okay, so that was about some introduction to a parabola and a quadratic function. Now let's look at the different general forms that we might come across in our syllabus while we will be dealing with quadratic functions. Okay, so first general form is something we call as a factored form. So in your factored form, you look at the equation in such a way: y is equals to a times x minus p times x minus q. So in this factored form, we should know a certain few things. We should know that the x-intercept are p and q. Okay. We should know that the axis of symmetry. Okay, so axis of symmetry is basically a line. So whenever we talk about axis of symmetry, we are talking about the equation of a straight line. So axis of symmetry is x is equals to p plus q divided by 2. And then the vertex has x coordinate. Okay, so vertex is basically a point in the Cartesian plane. It will have a x coordinate, it will have a y coordinate. We are simply talking about the x coordinate. So the vertex has a x coordinate as p plus q upon. What about the y coordinate? We don't know that. We'll have to put the value of x in the equation. We'll have to put the value of a, p, and q in the equation, and then we'll get the y coordinate. So that was about your factored form. Moving to the next form, which we call as a completed square form. So completed square form has an equation that looks like y is equals to a times x minus x whole square plus k, where your h, k, they belong to the real number. Okay. So in this completed square form, we can say that the axis of symmetry has an equation x is equals to h. In this completed square form, we can say that the vertex has a coordinate of h comma k. And what about the x-intercepts and y-intercepts? We cannot say that directly just by looking at the equation. So we need to solve it further. And then this completed square form can have its own version. So it can look like this. Y is equals to a x minus x whole square. There's no k. So if this is the case, then we can say that the x-intercept is h, just h. So this parabola will touch the x-axis at just a single point. We can say that the axis of symmetry has an equation that looks like x is equals to h. And finally, we can say that this parabola will have a vertex h comma 0. So I hope we are clear with the three different general forms that we can come across. And there's this one more, we'll talk about it a bit later. So let us talk about these three equations and something that all these three equations have in common. And apart from x and y, these three equations have in common is a. So let us talk about a, which is generally considered as the coefficient of x squared. Okay. So a few things about a. So firstly, if a is greater than 0, then we get something as concave upward. If a is less than 0, then we get parabola, which is concave downward. If you have a is equals to 0, then it will not be a quadratic equation anymore. It will become a linear equation. Okay, what else? So before I proceed to what else, let me show you something. So in a graph, in a Cartesian plane, this is how y is equals to x squared looks like. Okay, so if a lies between -1 and 1, then we say that whatever graph we are getting, it will be wider than y is equals to x square. What do I mean by that? It means if I have an equation that looks like, let's say, y is equals to uh, 0.5 times x minus p, x minus q, then the curve for this graph will look like this, will be wider. But on the other hand, if a is less than -1 or a is more than +1, then the graph is narrower. What do I mean by that? It means if I have an equation that looks like y is equals to 3 times x minus p times x minus q, then its graph would have looked something like this. Okay, so I hope we are clear with the three general forms. We are clear with identifying how a curve can look concave upward or a curve can look concave downward. So that was all for this video. In the next one, we are going to talk about how to sketch a graph by the completing square method by in the general form. And we'll be looking at positive definite and negative definite and all these things. So thank you so much everyone for watching.